Hello and welcome. My name is Wade Thompson. Today we'll be looking at the Fluke 1750 and exploring the unique feature sets along with a general overview of the product and applications. Let's start by looking at the common applications for the 1750. The benefits of the Fluke 1750 revolve around longer-term monitoring and the need to capture everything on every cycle simultaneously. Frequently, the nature of the problem is not clear or intermittent, making the setting of thresholds and memory allocation difficult. Power quality surveys are generally needed to be at least long enough to cover a full business cycle to capture all loads, and also nights and weekends, since some maintenance activity can occur then too. Typically, this would mean a full week of monitoring and frequently up to a month to capture full cycles and also random issues. Quality of service monitoring is done to verify that the power delivered from the utility is meeting expectations. This can also occur to make sure that the facility is not feeding something back unwanted to the utility. If the facility is co-generating or selling power back to the utility, it becomes critical that both sides have good visibility of the power at the common point. It is commonly recommended to test new installations to verify proper operation and also benchmark for future reference. On projects involving quality improvements or energy reduction, it is important to quantify the project's success by comparing before and after power data. In all applications, creating informative and professional reports can be done through the Fluke Power Analyze software. The Fluke 1750 is a turnkey kit with all the necessary parts included. It comes with a meter, an external 2 GB SD card, a PDA wireless front panel to interrogate the unit and also to assist in setup, 5 voltage leads and clips, 4 400 amp current probes, all the software for the PC and the PDA. The front panel of the 1750 is simple and straightforward. You have your AC power input, an external ground lug if necessary, 5 voltage inputs, and 5 current inputs. You also have the Ethernet RJ45 connector and the slot for the external SD card for transferring of data. The voltage connections are single lead or one cable per channel. The current probes also have single cable connections and have circuitry built in to tell the unit which probes are connected. This allows the software to automatically scale the data without any user settings. This will also allow the use of different style or range of current probes on each channel, so you can mix and match your current probes. The included PDA allows for interrogating the unit wirelessly, allowing the user to step away from the unit and work from a safe distance, and in many cases a more comfortable area. It also allows the ability to come back to the unit and look at readings without opening the cabinet or making physical connections. Main functions are the ability to look at the phasor diagram and waveforms to verify that the unit was connected correctly. The home screen brings all 3 data views in one, but each one can also be looked at individually, allowing for a full screen layout. The PDA can display a connection diagram for each power type, but most importantly, channels can be reassigned. If a connection mistake is found, one can make changes via the PDA rather than physically changing voltage or current probes. It will also allow inverting current probes via software in case the current probe is connected upside down. This is a big benefit both in safety and time. PC communications is done over a 100 base T Ethernet port using TCP/IP protocol. This allows for a direct connection from the 1750 to a computer running Microsoft Windows. The Ethernet cable can be either direct or crossover, as the unit will automatically compensate for the cable type. A DHCP client is also included to obtain an IP address automatically from a network server. The 1750 comes standard with 5 MHz sampling on voltage to give a detailed waveform view of transients up to 8,000 volts peak. As mentioned earlier, the 1750 does not require the setting of thresholds prior to monitoring. All the data is post-processed on the PC. This allows the user to change thresholds at any time while reviewing data, and the data is then retroactively changed, pulling more data forward or suppressing events accordingly. With all the data being captured simultaneously on all channels, along with post-processing, this opens the door to a couple other features. First is the ability to apply thresholds for voltage along with current. Also the ability to see what happened on all channels simultaneously and overlapped on the same graph, frequently referred to as cross-channel triggering. Also on the right-hand toolbar, there'll be choices to toggle different channels on and off so you can customize your views. Downloading data from the 1750 can be done in a couple of ways. The traditional way of connecting a laptop and downloading over Ethernet is the quickest and most straightforward way. In some cases, it may not be reasonable to carry a laptop around, so data can be transferred via a removable SD card. The unit can also be remotely downloaded via WAN or Internet, providing that firewalls or other security protocols will allow. Now let's shift our focus on the PC application, Fluke Power Analyze. This is the main screen in Fluke Power Analyze. In this example, we have a database already opened and displayed. Typically, the starting point is choosing a function from the toolbar on the left-hand side. The three tools highlighted are used when connected to a 1750 and allow for downloading data from a unit, viewing live scope mode, and also to make setup changes. The setup function in Fluke Power Analyze contains all the same items as the PDA. There is nothing exclusive to either one, simply a graphical layout difference due to the screen formats. The next three grouped above is to work with a database previously downloaded and saved on your PC. These will allow viewing of the